Hello and welcome to my video portfolio covering my work done on Mars Base 8. In the background there is a complete playthrough of a mechanical prototype that we gave to playtesters to get feedback on the base of our game. When setting out on the project, I was set the task of producing mechanical prototypes and creating a guiding narrative that the artist could then draw elements from to provide a more cohesive aesthetic for the assets. When we started the project, I pitched the idea of a space survival game where the player completes tasks during the day to keep the base running, but at night they are hunted by an alien that is damaging the base. This was used as the core idea, but the team made some tweaks. Rather than being set on a distant planet, we decided to set the game on Mars and pull elements from the film The Martian, which inspired the scavenger idea. Before we started designing mechanics and ideas for gameplay, we looked at the custom engine that we had. Luckily, we had both 2D and 3D rendering, which allowed us to use on-screen UI elements to help guide the player. At the time, one of the main concerns was how we were going to handle lighting, collision, and scale of the asset. Due to the fact that lighting would take considerable resources from the programmers to implement, we decided to put the nighttime section of the game into the stretch goal. This meant that the focus of the designers was to curate a list of daily tasks that a stranded explorer might need to perform each day. Since the majority of the narrative would have been explained during the nighttime portion, we decided to use its theming and overall setting to produce an implicit narrative for the player during the day. Since I was taking on the role of a technical designer, I brainstormed a wide range of mechanics and how they might function, with consideration to the location the game was set on. During the first weeks, we decided to go with a theme of being stranded on a planet, so my proposed mechanics were focused on scavenging and grunt work that a single person could perform. But due to concerns that this was highly limiting for what both the art and design teams could produce, we decided to shift towards our Mars base, where the player would act as a scientist that has been sent to fix some issues. This expanded the tasks that we could have the player perform, such as mineral analysis, repairing the habitat, and fixing solar panels. Before we began full-scale development, both me and the other designer came up with an asset list using Excel to provide the artist with some guidance on what assets we would like. We decided to use a priority system that allowed us to communicate in the document just how important certain assets were. We also added an assignment to each section so anyone could open the document and see who they needed to talk to about any asset to get changes to make it better fit in the location. One thing that took me longer to learn at the start of the project was Jira and how to create and progress tasks. This was essential as it gave us a central place where we could check what everyone was doing each week. Since I hadn't used the software before, I struggled with navigating the interface, but after a week I was creating tasks and providing timeframes and recorded times on them, which provided me with a clear track of what I had already done. The first stage of mechanic design I went through was to create a document with a list of mechanics I wanted to have and how they would work inside of the game. When I pitched this to the team, we decided to tweak a few of them to provide some variety. As the project progressed, I shifted to developing the mechanics inside of Unreal Engine, where I used the blueprint system to prototype the core mechanics. One of the early considerations I made when designing the mechanics was to give set modes for the player to be in that would govern how they interacted with the systems. I decided that doing it this way would allow us to reduce any conflicts that might happen inside the custom engine, as we could govern the items the player would be interacting with depending on the player's mode. One of my goals for the first few weeks was to have a basic Unreal blueprint for the watering plants function, breaking open geodes function, repair the hab function, and charging equipment. This provided the programmers with an idea of how I wanted the mechanics to function inside of the custom engine. By working on this whilst the programmers were combining their engines to provide all the functionality, it meant that they had a clear guide once they were finished. In the beginning, I made the watering can function as if it was slowly being filled by a tap, which increased the amount of water the player had, and decreased it when the player was holding down left click whilst in range of a plant. This feature faced a few issues when playing, as it was inconsistent for the player, as if they left the area of the specific plant it would cause errors. This was a minor issue, but since we were reworking how the mechanic would work, I decided not to spend time fixing the issue as it would waste time in the long run. Later in development, we came up with a central area for the player to interact with that they would fill with water, causing all of the plants to grow. This fixed three main issues we found during the playtests. 1. Players felt this task took far too long to complete compared to the others. This was because the original design had the player water each plant individually, which drastically increased the time it took for the task to be completed. 2. Players were unsure as to why a space colony would need a human to water each plant. This was something we overlooked originally, as we wanted to have the player grow plants in the habitat. With this central location, we decided to show it as a sprinkler system, which made more sense for the time and location, but also solved the first problem as well. 3. If a player runs around all the planters whilst holding down the fire input, it could cause lots of inconsistency and errors to happen. By changing the task to one main object, it simplified the task's technical requirements whilst also making it function more consistently. One of the complaints during playtesting was how the player didn't know how much water they had, apart from the debug text, which obviously wouldn't be in the full release of the game. To solve this, I added a progress bar that was visible when the player had the watering can and had filled it with some water. I placed this temporary bar in the rough area we decided for on the HUD. This allowed us to check if it was blocking too much of the player's vision before implementing it into the custom engine. This change was appreciated by the playtesters even if it wasn't using the final art assets. When reworking the watering task, I had to reorder how the chore grants its completion and the slow decrease of water to make it more consistent. This gives the player instant feedback to the chore being completed, whilst maintaining the slow decrease of water to simulate the water being poured out. I also used the rework to take the watering can from a one-time pickup to one where the player picks it up each day close to where the water filling area is. Moving on from the watering function, I used custom events to organize the different functions so people could easily see what each function was doing. This made it easy for the programmers to go into the main interact and see what was being done inside of each function. I also made use of Unreal's variable sorting system so people can see what variables are used in each function. For this project, I made use of enumerators to provide information and values to multiple blueprints at the same time. A good example of this is the geode collecting task, where 3 different blueprints wanted to know what type of rock the player had picked up. By using the enumerator, I am able to easily pass through what rock type it is to the player and to the rock analyzer. It also allows me to expand the list to add more rock types if we decide to. The geode collecting task allowed me to use both varied time and different textures to communicate what the player is analyzing. By doing this, the player can tell the longer it's scanning for, the more valuable the resource the player has found. Other tasks such as the system reboot were reduced due to technical limitations, as rather than using the typical PBR material for assets, we were using base color and an unlit texture. This allowed us to mimic how the assets looked inside of the custom engine inside of Unreal. Although since part of the system reboot task was red flashing lights, the unlit textures made this hard to see and didn't clearly communicate the urgency to the player. To work around this, we decided to make use of both sound and simple texture swaps. By playing an alarm sound when the task was active, the player is alerted. Even though simple texture swaps aren't as impactful and attention-drawing as flashing lights, it still gives us a visual way to communicate the task to the player. After I had all the core tasks functioning, I decided to create a document that contained the game flow. This detailed what tasks were active each day and the narrative reasons behind it. I presented this document to the group where we agreed on the flow, and I began implementing it into the original demo. To achieve this, I created a macro inside of the player's game mode that would enable the tasks associated with each day. It would also set the amount of chore points a chore would reward. This was to allow for the bonus tasks planned in the original game flow document, but after reconsideration, we decided that they lacked a reason for the player to interact with them. I decided to store this information inside the game mode, as it allows the player character to be changed and modified, for example, respawning the player if they died or went out of bounds, without risking the day progress or active tasks being changed. Since I was using the game mode, I could directly reference it from any blueprint, which could avoid any mistakes or casting errors. It also allows the player to be reduced down to just the actions and inputs rather than being the main storage for all of the game logic. One of the major challenges that I faced when developing inside of Unreal was changing between keyboard and controller input. This was because when I needed to test things quickly, I would just use the get key event inside of Unreal. When I was happy with how the mechanic was functioning, I would then go in and create an input binding. I made sure that these both contained keyboard and controller inputs, just in case I needed to quickly test something inside the editor. Due to my inexperience with input bindings, the first one that I created took a lot longer than planned, as I had to go inside of the Unreal documentation. To give you an example of how I went from concept to final build of a function, I will break down how I created the reboot task for the nighttime. In the beginning, I listed the different functions I wanted the feature to have. This was create a fog effect around the player to reduce their vision, reactivate the reboot system task. Once the player has rebooted the system, allow the next day to start. I then put this into a flowchart to break down the stages and what order they should go in. After getting the framework listed out, I worked on producing a fog effect that decreased the player's vision. To achieve this, I used a post-processing volume that covered the playable area and enabled if the player's game mode was set the reboot task as the nighttime task. Then I went into the reboot panel and added logic that allowed it to work in a new nighttime mode. After getting this set up, I added a check in the game mode for nighttime task complete, which was a boolean, that the reboot panel would change to true if it was complete. Over the course of Milestone 3, I performed weekly playtests within the team and with external playtesters. due to the custom engine being hard to access for external playtesters. We used the Unreal build with a controller to gather feedback and make changes to locations and mechanical feedback. Although this task required a lot of communication to set up playtests with people, it yielded feedback that prevented major issues towards the end of the project. The playtest allowed us to eliminate some of the developer bias and assumptions that we had made, which allowed us to quickly act and make player onboarding easy to follow. Early playtest allowed us to make major changes, such as giving the player a guide to each task, including the locations and objects they need to interact with and what the task wants them to do. To tie this in with the setting, I pitched the idea of an employee handbook which would allow us to convey this information to the player without breaking the immersion. I was able to arrange 5 playtests where I was able to see where players were struggling, which allowed me to pitch ideas back to the development team about changes we should be making. Inside the demo, there is a list that tells players what tasks are active each day. This is something that we implemented late into the engine build, alongside the screen that tells players the locations of tasks. However, inside engine, we have it working so once the player completes a task, it is ticked off so the player can keep track of what tasks they still need to do. This was something the playtesters were finding challenging about the demo build, as they would complete a task and be unsure as to which task they'd just completed. Although the playtests were useful to pitch changes, they also provided a good opportunity to gather feedback on the game's aesthetics and overall enjoyment of playing the game. Overall, all of the playtesters liked the art direction we decided to go with. This reinforced that our plan to focus programming time on mechanics and lighting worked out well and ensured that we didn't need to make major changes before the project ended. To gather feedback from the playtests, I made a form for the playtesters to fill in once they'd completed the demo, and made notes myself upon observations I'd made that I could take back to the team. As Milestone 3 progressed, I spent more time creating assets for the art team to fix problems raised in playtest. To do this, I produced a PowerPoint that was used as a template for the task guides that would display the locations of objects that the player would need for each task. At the same time, I was working with the programming team to ensure all of the mechanics were working correctly and the progression was as we planned. During this time, we optimized the flow of some of the tasks. Originally, the engine build had the reboot breakers task using 3 separate breakers, but after a discussion, we decided to reduce it to 2, as the one located in the bedroom was more of an annoyance if you missed it upon leaving the bedroom to get to the other 2, due to this being where the player would start anyway. Since lots of the player onboarding were designed later on by myself, the programmers required a lot more input on how the mechanics should function, as they weren't as thoroughly planned out in advance. When looking back on the project, I would say that I am extremely proud of what we've produced as a team. As for my own work, I am happy that I pushed myself to produce each mechanic inside of Unreal to guide the programmers on what their work should look like inside of the custom engine, although I wish I'd spent more time inside of the custom engine to have developed those skills more. After completing this project, I have learned a wide range of skills and greatly improved my development process and written communication, which can clearly be seen through my work communicating between both art and programming teams. Upon completion, we have a well-functioning demo that provides a nice snapshot of what a full game could be. Thank you for listening to my portfolio breakdown of my work on Mars Base 8.